Okay, good afternoon, everyone. Thanks for coming along. This is my first time at the conference, which I'm not quite sure how to pronounce its name, so you can maybe all just tell me it's Øredev. Close enough, okay. So my name's Robin. I work at a company called Confluence, who are one of the companies who contribute to the Apache Kafka project. We have our own distribution, our own hosted service, and so on. Out of interest, who's using Kafka at the moment? Quite a few. And who's never heard of Kafka but likes trains? Okay, a couple. So this talk is it's a very hands-on talk because I live in this place, Ilkley. It's almost as beautiful as around here. And I travel around, and my job is, it's called a developer advocate. So some of you may have heard of the idea. I only came across the idea a year or so ago. I didn't even realize it was a proper job. Turns out it is, kind of. And what I do is I go around different conferences, different meetups, I write blogs, and I just do Mickey Mouse demos that show here's this thing, and here's a Hello World example, and it's highly scalable, but it's Hello World. And I stole the idea from a colleague and a friend of mine. But I wanted to do something a bit more with it, to prove that I've still got the technical chops. I used to do this stuff properly. I used to be going to be a consultant. Now I work for a software company. Can I actually still do this kind of stuff? So I travel around a lot, and sometimes I get the train. Today I got the plane, and I almost didn't make it, but fortunately I did. But I get the train quite a lot as well, when I can do. And I was at the train station, I was thinking, well, trains make a great source of real-time data. Because the thing about building demos and building these things are if you work for a company, they're like, oh, here's all this data, can you build stuff with it? But if you're not working in a company itself, then you have to find these sources of data. And if you're talking about Kafka and events and event streaming, you need a real-time source of events. You can't just go and get all the historical stuff, which there's tons out there, but we wanted some real-time events. And over in the UK, we've got a company called Network Rail, and they have an open data source of rail data. So what I did was I use that to build out a platform around it to work out what can you actually do with Kafka beyond just oh, it's just a message bus, oh, it's just an ingestion pipe. Because Kafka is actually an event streaming platform. So plenty of you said you're using it at the moment. Most of you, I guess, have heard of it. But a lot of people think of Kafka as just this little function, when actually Kafka does a whole bunch of things. Kafka itself is a platform. Kafka's not just a message bus. Kafka's not just an ingest pipe into Hadoop. So Kafka's this great thing that you can actually build really cool things with. So I built really cool things with it. I built real-time visualization of the data. I did being able to analyze the data and drill down into actually what the data was showing us, understanding why trains get cancelled, which operators cancel the trains more often, but also looking at driving alerts from that data. So not just analytics, so doing real-time views of the data, doing analytics on the data, but also doing real-time notifications. So this idea that the events that power analytics are also the events that can power services. In this case, it was a simple service that just did a push notification. Oh, this train's been delayed. Oh, this train's being cancelled. But the events that power it, the events that we're using through Kafka are the same events that can be driving your services wherever they are and doing whatever they're doing, because they can just subscribe to a Kafka topic to get those events. So it looks like this. We've got a bunch of data coming into Kafka. Kafka is our event streaming platform. We do a bunch of transformations on the data and enrich it and cleanse it and do all that mucky stuff that you have to do with real data and not just hello world data. And then we use it. We stream it out to somewhere for analytics. We stream it somewhere for real-time visualization. We use it as a source for driving event-driven notifications. And all of this is done just using configuration and some SQL. So my background, mentioned earlier, used to do data warehousing at different retailers. I was a consultant building data warehouses. I don't actually write code. Well, I write SQL, but I can't write any Java. I write Python, but I'm particularly bad at it. But everything that I've built out here is just using configuration to say, get the data from here, push the data over there, and SQL to say, here's how I want to transform it. But doing so as a stream processing application. So all the code is online if you don't believe me. If you think, well, there must be a bit of SQL, a bit of Java sticking around somewhere. There isn't, I promise. It's all on GitHub. You can actually clone it from there and run it yourselves if you want to. You can just go and sign up for the API at the open data source and actually build it out yourself. I'll share all the slides afterwards. I'll tweet them and I'll do all sorts of stuff like that. So if you miss the URL, you can get it from there. So the first thing is, how do you actually get the data in? So most of the data, like the real-time data itself, comes from this open data source, and they make it available using ActiveMQ. So whatever their systems are internally, ActiveMQ is their endpoint through which they expose it. And then there's reference information about like the schedules of the trains, and you start like having to understand quite a lot about the data model. That's sat in S3 buckets. There's also data coming from other different sources like flat files and websites. But we've got all of this data that we need to get in. The way that you get data into Kafka almost always should be Kafka Connect. So if you're using Kafka today, and you're getting data into Kafka by like writing programs that go and poll this thing over here and push the data into Kafka, or you've got data in Kafka that you're pushing out to other places, and it's like, oh, well, I'll go and write a Spark job, and it'll take this, and it'll push it up to there. Possibly, this will be good news for you, because Kafka, or maybe not if you kind of like wasted all your time on that, but Kafka Connect lets you do streaming integration between systems upstream and into Kafka, and from Kafka down to systems downstream. And it's scalable, it's part of Apache Kafka, it's fault tolerant, it manages your schemas, it manages your restarts, it's pretty clever. I also use this excellent tool called Kafka Cat. So this is a great little tips and tricks. If you're using Kafka, go and investigate Kafka Cat. This is a fantastic little tool to have in your toolbox. It integrates superbly with Linux pipes, so you can like pipe data into a topic or consume data out and pipe it into something else. It's a really nifty little way of handling data. So the bulk of the data, like I say, it comes from ActiveMQ. And it characterizes the movement data. So movement is like a train arrived at a station, it went past a set of points, it went to signals, it left a station, and it's got stuff like what was the train's identifier, what platform was it at, what time was it, all stuff like that. It's like a real-time feed of data. And so this we stream into Kafka using Kafka Connect. So Kafka Connect is this framework. It's part of Apache Kafka, and you just plug in the appropriate connector. So I've got data in ActiveMQ, I'll get the ActiveMQ connector and plug it in, and off we go. Or I've got data sat in a database, I'll go and get the appropriate database connector and do change data capture out of a database into Kafka. I've got data sat in a flat file on a REST endpoint. Wherever you've got your sources of data, you can stream it into Kafka using Kafka Connect. So we've got the data in ActiveMQ, different kind of queues on ActiveMQ for different train operating companies. You stream the data from there through Kafka Connect into this single topic. So here's where the real world hits hello world, because that's the hello world. It's like, oh, it's easy. Source, target, done. But actually, the data that we get is kind of wrapped in this envelope. So you've got like the ActiveMQ envelope about the payload, and then you've got the payload itself. And we want to work with a payload. The payload itself, it looks like that. It's a JSON, kind of like within an array. So we need to transform it. We need to explode it out, because this is what we're actually interested in. This is the payload itself. So to do this, we use Kafka Cat. We could write some code. If we were going to productionize it and rely on it, we could go and probably write some better code. But this is surprisingly effective. Kafka Cat consumes from the source topic. It pipes it through JQ. So if you know JQ, it's a fantastic little tool for manipulating JSON. It pulls out the JSON, it explodes it, it deserializes it, and then pipes it back through Kafka Cat to another Kafka topic. So you can set up these little different pipelines just using command line tools and Kafka. The schedule data is like information about the trains and like what type of train was it, what was the rolling stock, can you make reservations, all that kind of interesting stuff if you like your trains. And this lets us understand about the movements. Like train ID 42 was at this station. Well, where was it going from? Where was it going to? What kind of train is it? And so on and so on. So this reference information, it's sat up on an S3 bucket. Again, a cheeky little bit of Kafka Cat. We're going to curl to pull it down from the bucket, unzip it on the way, pipe it through gunzip, pipe it into Kafka Cat. The same with the other reference data. So there are things like location information. So the trains are moving all around the network. One of the things that's useful to know is like, well, where are they? Because when we visualize this, it'll be quite nice to see it on a map. So we can pull out the geocode information. There's various open source places that let you do that. So we can use a curl command to pull that information out, and again, pipe it into a JSON file and through into Kafka Cat. Static reference information from websites, scrape it out, stick it in a file, Kafka Cat. So there are different ways of getting data in, but all of it revolves around using Kafka Connect or Kafka Cat. Some of the Kafka Cat stuff is a little bit hacky, but hey, this is a side project. It works, and it works good enough. Kafka Connect is an open API. It's part of Apache Kafka. So if you want to kind of formalize your ingest and actually write some proper code to do this thing reliably and scalably and so on, you'd write a connector for Kafka Connect. But the brilliant thing about Kafka Connect is it handles the kind of framework stuff for you. It handles how do I scale out? Something went bang, how do I restart? Where did I get to in my point of ingest? What do I do with a schema? All of that stuff, if you're writing this stuff for yourself by hand, you have to worry about. Kafka Connect worries about it for you. If you write a Kafka Connect connector, all you simply need to do is, I know about the particular technology I'm connecting to, I just worry about that interface. Kafka Connect does all the rest. So we've got the data in. Kafka Connect, Kafka Cat, by hook or by crook, we've got the data coming in. It's streaming to Kafka topics. Now, we need to transform it. Because at the moment, all we've got is kind of like various different Kafka topics of like some event information, some reference information, and we need to make sense of this. We need to understand what these different movement records, how do they relate to the different trains, and so on. And so here, we need to understand the data model. Again, real-world type stuff. Data models aren't always easy. They're not always clean. They're not always perfect. So movements are like one of our core entities. It's like it's a train, and it moved. And it moved to a location and from a location. So you've got many different movements associated with a location. And then we've got schedules. Schedules are also related to locations. And then activations are this funny thing that define the relationship between a train that's moved and its schedule. It's like a schedule is like, we plan that this will happen, like next week there'll be a train running between here and here at this time. Train movement has got an ID, the activation like links the two together. So we've got a data model that we understand. And now we need a way of manipulating this stream of data, this stream of events that's coming through from ActiveMQ. How do we manipulate that to understand, to build those different relationships and actually realize them in the data? So to do the processing, we need to take these different events that are arriving over time, and we need to process them. And to do this, we can use something called KSQL. Has anyone tried KSQL? Has anyone heard? Oh, one person, 2 people, brilliant. Any advance on 2? I'll stick with 2 for now, but all go and try it out afterwards. KSQL lets you build stream processing applications and express it using SQL. So it lets you say, like, well, I've got an inbound stream of widgets, and like red widgets, yellow widgets, they're arriving over time, they're events in a Kafka topic, they're arriving from wherever, however, and I'd like to create a derived stream. I'm interested only in red widgets. I've written a fancy new microservice. It needs to know about red widget events when they happen, as soon as they happen. So I can write a KSQL application which simply says, create this new stream, red widgets, select star from the inbound stream, write it out to the new one where, predicate. So we can now filter out these events as they're happening and write it out to a new Kafka topic. And that's your stream processing application. You take that, that's your code base. You deploy that onto your KSQL server. There's no kind of boilerplate crap around it. That's your stream processing application. So we can take all of these different inbound sources and we can process them using KSQL to start enriching the data, start cleansing the data, to start actually building some analytics around the data. So the first bit we're going to do, we're going to take the data that comes from ActiveMQ, and we're going to work out, well, how do we manipulate this data? Because within this single queue that comes from ActiveMQ, the movement data, you actually have different entities. You have movements, you have activations, you have cancellations, you have all these different types of records. One of the great things about building this project was it reminds you how dirty real-world data can be. Like, it wouldn't be great if there were all these different queues. Well, no. Turns out there's just one. And now it's my job as a developer to figure out, well, how do I resolve that and how do I make it workable for what I'm trying to build? So in this case, I make it workable using KSQL. Let's take an inbound stream of events, and we're going to route them based on their message type that's in the data out to different Kafka topics. So we say, create a movement stream, select star from the inbound where message type is 003. Create another stream, cancellations, where message type 002. So you can take your inbound messages as they're arriving and start routing them out to different Kafka topics based on their properties. You can also do joins in KSQL. So there's something called the stream table duality. I'm doing another talk today, shameless plug, 20 past 4, and I'm going to talk all about kind of like Kafka from like an architectural point of view and get kind of like a bit hand-wavy. And I'm going to explain in much more detail then this thing called the stream table duality. But in essence, it lets us reason about a stream of events, which is what Kafka topics are. Kafka topics are this immutable stream of events. It lets us reason about those either as a stream, which is like what we think of topics as. It also lets us reason about them as a table. Okay? Databases, tables, state, Kafka, streams. Turns out Kafka also can reason about state by taking a Kafka topic, a stream of events, and you can treat it as if it's state. For a particular key, tell me what the state is. So the information about our locations, our static reference information that we loaded earlier, scraped from a web page or done something from a S3 bucket, we've streamed that into a Kafka topic, and we can take that topic and treat it as a table, which means we can take these inbound movements. So a train at 1 minute past 10 was at location 42. That's our event data, our fact data coming through from the source system. And we can join that out to a table, and we can enrich it. We can write a new Kafka topic by saying, create stream, select the location, the description from movements, join, left join out to the location on primary key, foreign key. So using KSQL, which is built on Kafka streams, so if you prefer to do this in Java, you can use Kafka streams, which is like a lower level API. You can actually take streams of data, join it to, in effect, a table of data, but it's still a Kafka topic. You can use KSQL to enrich the data. So you can create composite keys. You can say, in my source of data, I can't uniquely identify these records on this particular column alone. I need to build a composite key, the kind of like the business logic key. You can concatenate columns together. You can also decode values. You can say, here, I've got a power type E, a power type D. Is that electric? Is it diesel? Well, I guess it is. One option would be create a new table, a lookup table, and do a join out to that. Another option would be simply to hard code it and say, well, do a case statement. If the power type is D, then it's diesel. If the power type's E, then it's electric. So the same kind of logic that we would build into a SQL statement in like an ETL process or in a database statement, you can also do on data that's flowing through Kafka. So you can do joins out to lookup tables. You can also just embed that decode logic within your SQL itself. Schemas are surprisingly important. Schemas went out of fashion a few years ago. Like big data came along and everyone was like, chuck the schemas away, worry about it, we'll do a schema on read. We can just like chuck the data in, like we'll do a schema on read. But schemas are fantastically important. Whether we're building applications and services, whether we're building our analytics platforms, the schemas to our data almost always exist. It's just, can we be bothered to kind of like enforce them and care about them? And if you don't care about them, you're going to end up in a right old pickle and wish that you had a few months later. So when you're building things with Kafka, there's support for schemas. So the data that I'm pulling in is in JSON. So KSQL works with JSON. I've had to declare the schema. I've had to go to the owner of the data, or I got given, here is the schema of the data. It's got these different columns. They've got these particular data types. And I had to type the schema in, which is error-prone and laborious, but hey, we did it. And we say the value format is JSON. And that JSON data, we can work with nested. So we can take a struct. We can also model an entire JSON lump as just like a big varchar. And then subsequent steps, we can say, well, we're going to extract the particular columns. Because it might be you've got like 20,000 different fields within that JSON lump. You only want a couple of them. So instead of typing out every single one, you could just say we're going to create it as a lump, and when we reference it, we'll just pull out the fields that we want. So within the lump of JSON, the cancellation timestamp, the cancellation reason code, and then we can pull those out as actual columns. So KSQL can apply schemas as well. It can say, here's this lump of data, and now we're going to name these fields. Or we're going to select this field and rename it to another name. But ultimately, JSON is not the best way to manage data with schemas. Don't at me. Talk to me afterwards if you disagree. The best way to handle data with schemas is something like Avro, is something like Protobuf, is like something which has strong support, opinionated support for schemas. Because the schemas exist, whether you like it or not. It's just, are you going to actually enforce them in the applications that you're building? My colleague, Gwen Shapiro, has this great quotation here. She also talks about schemas as being your API between your services. They're the contract between your services. If you're starting to like break up your monoliths and build out all these services and using events to do communication between them, if you're not enforcing a schema compatibility, you're basically saying, well, fingers crossed this will work. Fingers crossed they don't change what they're sending. Fingers crossed they don't change what they're expecting. And it's all a bit of a guess. We say, oh, well, we'll put it on GitHub, and we'll check it in, check it out, and then someone else forgets to. Or we could email over to each other what it is, or we could have a change committee meeting if we want to change the schema. Like all those kind of crappy ways of doing things that we always used to. So using something like Avro lets you declare and enforce a schema on the data that you've got in Kafka. So if you use Avro, you've got the Schema Registry, which gives you somewhere to store your schema. So this is how it works. Whether you're using KSQL, whether you're using your own Kafka producer, whether you're using Kafka Connect, whatever you're using that's writing your data into Kafka, it uses the Avro serializer, serializes the message into this small little binary format which goes onto the Kafka topic, and it puts the schema up in the Schema Registry. So on your Kafka topic, because Kafka topics, remember, they're just key value bytes. Kafka doesn't care what format your data's in, it's just bytes. So you have to manage it at the serialization, deserialization stage. So you're using Avro, your serializer, whether it's KSQL, Connect, your own producer, serializes the data onto Avro, puts the schema up in the Schema Registry, and then anyone who wants to use the data, whether it's a consumer, KSQL, Kafka Connect, or all three, they simply connect to the topic, they pull down the Avro message, the deserializer says, aha, it's Avro, here's the ID that's embedded in it, pulls down the schema from the Schema Registry, and can now deserialize that data. So if you're writing your Java programs, you can build the code automatically. If you're using Kafka Connect, it simply pulls the message, pushes it down to the target. If the target supports the concept of schemas, like a relational database, it'll build the target object, because the schemas matter. So schemas can carry through from source through to target, so long as you're actually caring for them by using something like Avro, which supports them. If you're just using JSON, it's just a lump of strings. You then have to declare at the source and target, well, what's this actually look like? So you can reserialize your data in KSQL. So whatever it starts off as, whether it's CSV, whether it's JSON, whether it's whatever it is, KSQL supports CSV, JSON, and Avro. It can read CSV, it can read JSON, and you can say when I create derived streams of data, I apply my transformations to it, I take my inbound source of JSON data, I'm going to write out my cancellation stream, I'm going to write my cancellation stream as Avro. So now anyone reading those cancellations, they have access to the schema. They don't have to type it in themselves, which gets kind of tedious. KSQL can also flatten your schemas. So if you've got like a highly nested structure and you want to flatten it out for whatever reason, you can do that. You can also rekey it. So you're keying your data based on a business key or a partitioning key or whatever. You can say to KSQL, I'd like to repartition it when we're writing out to the new topic. Change the number of partitions, change the partitioning key as well if you want to. So this is what you end up with. You end up with a lot of small text that you're not going to read. It's there for illustrative purposes only. You end up with this kind of like daisy chain of sequences. We're pulling the data in at various different points. We're starting to merge it together. We're starting to enrich it, transform it, and write it out to a series of target topics from which we can then consume the data. As I say, all the slides are put online. That diagram there, actually, it's a Google Draw document. I can share the link to that as well so you can actually understand what's fully going on. So we've got the data. It flows in. We transform it. All of this is obviously event-driven, so as a movement happens, we get it into Kafka, we transform it, write it out to the target topic. So each of the KSQL steps writes out to a new topic. So when it's doing its processing, the result of the KSQL statement goes onto a Kafka topic. And those Kafka topics we can consume. So we use Kafka Connect in all of these cases to take the data from a Kafka topic and stream it to a target system for various different purposes. So a brief reminder, Kafka Connect, streaming integration between systems both upstream and downstream of Kafka. And it's just JSON-based, just JSON configuration. So we say, I'd like to get my data from Kafka to Elasticsearch. It's like, that's all right. We'll use the Elasticsearch sync connector. It's quite an obvious name because it's a sync to Elasticsearch. Which topic do we want? Well, we want the train movements activation schedule 00. Naming was never my forte. And where do we want to put it? Well, we want to put it into Elasticsearch. And there's the connection URL. So it's as simple as that. So then Kafka Connect says, well, there's this topic, and I can send it over there. And if there's lots of different topics, you can scale me out, and I'll do it super fast. And if one of them goes bang, well, I'll restart the work over there. I don't have to worry about any of that. Kafka Connect does it for me. So then we get the data through into Elasticsearch. We can stick Kibana on top. And it's worth kind of like taking a step back and thinking what we've got here. We've got a real-time view of the data that you can put in front of a business user and say, here's your real-time analysis. You can click around and you can drag on it or whatever, that we've created by pulling in data from a source system by writing some JSON to ingest it. We've written a bit of SQL to enrich it and transform it, and a bit more JSON to write it into Elasticsearch. And from that, we've got very powerful dashboards that we can put in front of our users who can do all sorts of fancy type stuff. We can also take the data, go and stick it in a database. Maybe we want to use a database for whatever reason. A lot of the time, though, Kafka serves as the integration platform. The data comes in, the data is available in Kafka. Different teams say, well, I'd like that data. Well, I'd like that data. Oh, it turns out that I'd like that data as well. But, oh, yeah, we use Postgres, but we use MySQL, or we're using Aurora. Well, fine. Kafka Connect can stream it to various different places. So maybe you've got your data science team and saying, well, we want to start analyzing this train data that you've got, and that's great that you've cleansed it and written it back into Kafka for us. So we're going to hook up Kafka down to a database using Kafka Connect. And now we've got that data streaming down into Postgres, and we can start to analyze it. We can start to do our data science-y type stuff. We can start to do crosstabs and pivots and all that kind of funky stuff. We can write some clever SQL that says, for each train operating company, how many times was a train late, how many times was it early, how many times did it get lost or go off route or whatever. The kind of data science-y type analytics stuff we do. But I'll pose you this question. We've got data in Kafka. Kafka persists data. I may not have mentioned that already, in case you didn't know. Kafka persists data for as long as you want. When you read a message from Kafka, it does not get deleted. When you read a message from Kafka, all that happens is the offset changes for your particular consumer. The log is persisted for as long as you want. So you can keep data in Kafka for a day, a second, a minute, a month, a week, forever. It's up to you. So you've got this data in Kafka, and we're saying, well, we're going to stream it to a database because we want to do some analytics on it. But we've also said with KSQL and with Kafka streams, you can run kind of joins, you can do cleaning the data, you can build aggregates as well. And you can treat table data in a Kafka topic as if it's a table. You can like examine the state of the data. So do we actually need to put it in Postgres at all? Because in KSQL, and this is valid KSQL, you could say, I'd like to see by train operating company, how many were en route, how many were late, how many were early, and that's just using the data in Kafka. So sometimes, I can see a few little, yeah, this guy's talking rubbish. Sometimes you do want to go and put it into a database. You do want to go and put it into S3, which I'll show in a moment, for your long-term, ad hoc, data science-y funky stuff, because you want that big store that you're going to do lots of kind of ad hoc querying against. But sometimes the pattern you're following is, I need to write it to a data store so that my application can query the state, so that my application can show this thing. Well, if you're doing that, your application can query the state and do its thing based on the data in Kafka itself. You don't need that additional data store. If all you're doing is take the data from Kafka, stream it into this data store to then do some computation on state to then show it in your application, you can do that in Kafka with KSQL or Kafka streams. Just food for thought. So we can put it in S3. Data scientists say this guy's talking rubbish. We need it in S3. S3 is where we put our data for our data lake for the Magic Fairies to do their Magic Fairy stuff, because we're going to put in S3, we're going to build a data lake. So we're going to use the S3 sync connector. Again, it's cleverly named. But again, bit of JSON. Here's the topic. Here's where we want to put it. We get it into our S3 bucket. This was something I was interested in. Like I say, I used to build data warehouses. I used to kind of do that kind of stuff. And as I was just coming out of that, the whole big data thing was kicking off, and I was looking at Amazon. And one of the things a couple of years ago was AWS Glue. And it had this idea that it could kind of go and crawl your data. Does anyone use AWS Glue today? OK, so you're all new to it like I was. This is pretty cool. You basically point it at an S3 bucket, and it just goes and infers a whole bunch of stuff about the data. It works out that it's partitioned into these different folders within the bucket, and it's got this kind of schema, and so here's your table. So I can go and create that table, and then you can query your data in Athena, which is pretty cool. So if you're doing that kind of ad hoc analytics against your data, you're going to put it in a database. You might want to go and put it into S3. Using something like Glue to kind of just go and figure out stuff certainly makes it quicker to get from like chuck it in to I can run queries. So again, this is doing funky stuff on it. This was doing something that I couldn't do within KSQL, which was to do kind of with like nested arrays and like some proper funky type stuff. The whole point in all of this is that Kafka lets you use the most appropriate tool for the job you're trying to do. The mistake that a lot of us fall into is like, here's this kind of like bog standard box that I'm used to, and kind of like, I know what it is, and I've always used this, and it's never gone particularly wrong, so I'll just use it again. Why not? That's how we build a lot of our systems. No one got fired for like using this generic kind of box in the middle. But actually, we've got lots of different boxes available to us now, so we can use the most appropriate one. If I want to kind of look at the real-time state on streams of data, I don't need a database. I can do it in Kafka Streams or KSQL. If I want to do ad hoc queries against big lumps of data, trying to do that from a Kafka topic is going to suck, because Kafka topics are sequential. And you're going to do the equivalent of a full table scan if you start kind of like just scanning through big chunks of data. So sometimes you do want to go and put it somewhere else. So you can go and put it in S3. You can do your analytics there. But defaulting to these things just because that's what we've always done, that's what Kafka lets you avoid doing, because it gives you the choice of where do I want my data, where do I want to transform my data, where do I want to analyze my data. Turns out I want to do some property graph analysis. Now this one I hold my hands up to is simply because it looks cool on screen. I've not actually figured out the property graph model to the train data. I believe there is a good one to do. But the point is, if you've got data that you want to do graph analysis on, you set up a Kafka Connect connector, you say, I would like to send it down to Neo4j, here's my Cypher query that describes how to model it, and then you can go and do nice screenshots like that. More semi-seriously, you can also use the event data that we've got flowing into Kafka to drive your applications. So far, I've talked mostly about analytics and real-time analytics, and that's kind of like, that's one segment of the developer base. But actually, there's a whole bunch of people that say, well, I'm building applications that are driven by events. When something happens, I need to do something. When an order gets placed, I need to know about it. And by using Kafka and using Kafka Connect and KSQL, you can actually build a lot of stuff out like that. So this is an example of taking the train information that we've seen so far, ingested in exactly the same way on the same topics that are populating like Kibana and Elasticsearch downstream or S3 or whatever, the same topics, we can also use to drive this kind of alerting. So we can say, if a particular train at a particular station arrives beyond a certain threshold, so if an event happens beyond a given SLA, let's trigger an alert. So I'm using Telegram. If you're not familiar with it, it's like WhatsApp, like Messenger, like it's just a messaging thing. And it's got an API, which is kind of cool. So it means we can do this. We can take our stream of movements. So a train went here, a train went there, a train went there. And that movement data we've now enriched. So we've put in information about the station and what time it arrived and how late was it and so on and so on. And we've got a separate Kafka topic called alert config. And this gives us our configuration for our alerts. So we say, at this particular station, if it was arrived at Leeds station more than 20 minutes late, we want to send an alert. If it arrived at Ilkley station more than 5 minutes late, we want to send an alert. So we've got variable alerting based on this configuration in a Kafka topic. So this Kafka topic here is going to be treated as a table. We're going to say, what's the state for the current key? The key is the station. Because it could be, we say, well, actually, instead of 5 minutes at Ilkley, we want it to be 10 minutes. You simply put another message onto that topic, and then that state negates the previous one, so the state for Ilkley is now 10 minutes. But it means you can have your dynamic alerting like that. and then you simply join between them. So do a join between the movements and the alert config, and do an inner join. So if there's no match found on the alert config, we don't get a return. And we also stick a predicate in there where the variation of the train is greater than alert. So that gets written to a new Kafka topic. So that's our alerting built as a KSQL application. Okay, one set of SQL, create a new Kafka topic based on this condition, joining out to this topic. And then we use Kafka Connect again. Kafka Connect has got HTTP sync. It can invoke HTTP calls. It can call out, in effect, to Telegram and push a message. A message arrives on this topic. We're going to push it out to Telegram. This, I would love to go into. It talks about compacted topics, but I'm running out of time. The slides are online. I can explain it afterwards if anyone would like to know. So that's kind of what I built. And as I say, it was a side project. It was a kind of like, can I still do this? Is this stuff I'm talking about actually fit for purpose, or am I just like talking gobtollop? Turns out, I think it's very fit for purpose. I think it's a fantastic platform on which to be building things. So for monitoring it, you've got Confluent Control Center, which gives you like the lag between the different consumers. You can look at your throughputs, you can look at your system health, and kind of keep an eye on it through that. Bits of it are hacky. Bits of it use cron tab to kind of like restart stuff if it's failed. There's a bash script to show like, are all the connectors up and running? When was the latest timestamp that we got into Elasticsearch? You can go and use Kafka Cat, again, my favorite friend, to pull down data from a topic and work out the latest date. But little things like that if you're actually going to run this, you kind of need. So this is what we had. Data coming in from ActiveMQ, our events flowing in from ActiveMQ, a bunch of reference data coming in from S3, from flat files, from websites and whatever. All of that streamed into Kafka, using KSQL to enrich, to cleanse, to join the data, to transform the data, and then Kafka Connect to push it out to various different targets for use. All of it, configuration, SQL, configuration. If you want to try it out, Confluent Cloud gives you a managed Kafka service. It also gives you KSQL, Kafka Connect, Schema Registry as a managed thing. There's a $50 free entry thing that you can use as well and sign up and try for there. If you want to learn more about Kafka, go to that URL, type in your email address, and you can pull down all of those ebooks for free. They are very, very good books. So Gwen Shapira, Neha Nakedi, Tom Paulino, and Neha wrote Kafka, the original Kafka. So these are seriously good books. Depending on your particular interest in things, the event-driven systems one, also very interesting. As I say, I'll tweet, I'll share those slides. I think the QR code should work if you take a photo of it. I'll put it back on at the end. If you're interested in hearing me more wave my hands and rant about Kafka and why it's appropriate, today at 4:20, it's a kind of like an architectural view of Kafka, event-driven systems, what events are. I've talked about events, but actually what are they? Why are they so important at 4:20? So thank you very much for your time.